everyone, welcome to Helm of Science. So we have started off with this series of revision regarding the different chapters which can come in your competitive examinations. Now one thing which I would like to mention is since the ICSE, ISC, CBSE exams have been cancelled, so we can now concentrate on the preparation of our competitive examinations without being in a kind of dicey situation as to which one to focus on, right? So now I believe that everybody will be putting in their equal efforts so that all of you can qualify your competitive examinations. And this is a small help from my side so that I can give you certain questions for your practice so that you can improve your concepts and your the knowledge of the chapter. So today's topic of discussion will be periodic table, which was or rather I would say periodic classification and periodic properties, which was a chapter that was there in your class 11. Now since the joint entrance examination is based on both 11 and 12, so we have to give equal importance to both the classes, right? So we will be doing a chapter from 11 today, that is periodic table or periodic classification of elements and their corresponding properties. Without wasting any more time, let us just get into the details of the chapter. So the first question that is said is the IUPAC name of an element with atomic number 119 would be. Now you might be thinking that what am I actually discussing? I mean, these kind of questions hardly come in the examinations. These are very basic, very childish kind of questions. But just let me tell you that any kind of competitive exams is unpredictable, right? So there is nothing like this cannot come. Anything can come for the exam and which cannot be predicted. Like this question has been given in the examination in a very recent time, that is 2019 April session. So that is just about 2 years back. So anything which is basic and will not come is not a question, alright? Everything can come, and so we have to be prepared simultaneously. So this question I think everybody can answer. So atomic number 119 would be, we would write it as un, and this would be nona, and there should be a em to it at the end of the name, right? So what should we give the abbreviation as? The abbreviation would be U, the first letter of each, U, and N. So this would be a correct answer. Answer would be option number C. Right? So this is a very basic question, very, very simple, very flat question. Now question number 2, another very basic question, that is the group number of valence electrons and valency of an element with atomic number 15. So the Z mentioned to you is 15. Now you can go by the classical concept of the distributing the electrons in the shells like we have done in our junior classes, or you can go with the writing of the electronic configuration using the noble gas configuration. Whichever you're comfortable with, you can do it. So 15 atomic number would be distributed in 3 energy levels or energy shells according to the octet and duplet rule as 2, 8 and 5. Right? So from this we can say that the group number would be depending on the valence electrons. When it is more than 3 or more than 3, we add 10 to it to get the group number. So our group number would be 15. Okay. Valence electrons are the electrons in the outermost shell, which is 5. And what else do we have in our question is the valency, I think. So valency is the number of electrons required or number of electrons lost to attain a stable electronic configuration. Now it has 5 valence electrons in its outermost shell. So we can say that it needs 3 more electrons to complete its octet. Now you can say, ma'am, why not lose the 5 electrons so that we can get the octet here? But that's not possible. Losing 5 electrons is very tough. You will require a greater amount of energy. So it will be much more easier if this particular element acquires 3 electrons to complete its octet. So it will be gaining 3 electrons plus 3 electrons. And addition of electrons means addition of negative charge. So the valency would be 3. Right? Now there is no minus or plus mentioned in the option. So you can just keep it as 3 as your valency. So the answer would be option number B. Right? 15, 5 and 3. Alright? Okay. The next question is the correct order of atomic radii of carbon, cesium, aluminium and sulfur. 4 elements have been given and you have to arrange it in the correct order of atomic size. Now we know, children, that atomic size decreases across a period and increases down the group. Right? So if we have to use it on that basis, then what would we say? Carbon, cesium, aluminium and sulfur is given. Now, aluminium and sulfur is in the same period, right? So there is no changes in that. Now coming to carbon, carbon is a period above aluminium and sulfur. That is, if aluminium and sulfur is present in period number 3, then carbon is present in period number 2, right? Now, cesium is present in group 1 and group 1, right? In the alkali metal group, correct? And it is way down in the group. So this is a little odd, if I would say, compared to the rest. So if you have to compare in terms of the same element which is on the same period, that is aluminium and sulfur, we would say the thing is aluminium, silicon, phosphorus and sulfur, 13, 14, 15 and 16, right? Group numbers. So as we move across the period, then the size should decrease. So why should the size decrease? Because the effective nuclear charge increases as the number of electrons increases. Right? The pull of the nucleus on the outermost electrons kind of increases. So the size contracts, so there is a decrease in the size. Now, so if size decreases across a period, so aluminium would be greater than sulfur. That is for sure. Right? Now, aluminium and sulfur is below carbon, right? In the period which is next to carbon, like that is period 3. So you can say it is in a downward position. So as we move across a period, the size decreases, and as we move down a group, the size increases. Correct? So we can obviously say that aluminium and sulfur would be having a greater atomic size than carbon as compared to carbon. Yes or no? Right? So aluminium and sulfur no doubt will have a greater atomic size than that of carbon. That is for sure. Now, cesium lies way below in the periodic table. So, this should have the maximum size. Right? So, this should be my order. And this, I think, matches with option number A. That is, A would be your correct option. I hope it is clear how you have to analyze a particular question when it comes in your exam. Okay. A very similar question is given to you in the next one. That is, the ionic radii of nitride ion, oxide ion and fluoride ion. The order would be which one? Rather, they have given the values. Now, you don't have to memorize the values. You just have to analyze that which value matches with which one. Right? Now, the ions that have been given to you. Now, what is the difference between this question and the previous question? In the previous question, it was mentioned in terms of atomic size. Right? Now, here they have mentioned in terms of ions. Correct? So we have is N3 minus, O2 minus and F minus. These are the 3. Now if it was of no charge, so elemental nitrogen should have how many protons? 7 protons. But now when it is having a 3 minus charge, it should have electrons equal to 10, because if it was in the atomic state, then protons and electrons would be equal to 7 each. Now it is having a charge of -3. So electrons would increase to 10 electrons. Correct? Similarly, for oxygen, if it was in the elemental state, then the number of protons would be 8. Electrons would also be 8. But since there is a -2 charge here, electrons will be 10. Moving on to fluorine, it should have been 9 and electrons should have been 9, but there is a minus charge, so this should be 10. Correct? So we can see that the electrons here are the same. So how can we compare? We can compare is using the proton part. How do we do it? See, if there are greater number of protons, since the electrons are fixed, if there are greater number of protons, it will attract the negative charges much more stronger, because this is a positive charge entity, proton, and the electron is a negative charge entity. So opposite charges will kind of attract. So if the proton number is higher, then it would attract the electrons to a greater extent. So far clear? So ideally, since the number of protons is greatest in this case, in the case of fluorine or fluoride ion, it should attract the electrons to a greater extent as compared to the nitride and oxide ion. So its size should be comparatively smaller as compared to these two. So F minus should have the least size. Then will come O2 minus using the same justification and logic. And N3 minus would be the highest because its proton number is least and it will not be able to attract the electrons to that extent. So this is what we have got the order as. So now if you want to match the values, what are the values given? 1.36, 1.40, 1.71, right? So the highest value would be 1.71 for nitride. For oxygen, it should be 1.40. And for fluorine, it should be 1.36. So we have to see that 1.7, 1.40, 1.36. That is option number C is your correct answer. Alright. So I hope it's clear the logic as to how we have to approach a particular question in the examinations. Alright. Now moving on to the next question is, which one of the following alkaline earth metal sulfates has its hydration enthalpy greater than its lattice enthalpy? Now this is a very good question and very conceptual as well. So there are two terms that has been given to you. One is hydration enthalpy and one is lattice enthalpy. These are the two words. Now what do these words mean is very important. Alright. Now enthalpy is nothing but a form of energy. Okay, understand it in a very simple context that enthalpy is nothing but a form of energy. Alright. Now, if it is a form of energy, then what? Then we can also simplify it and say that we are discussing about the hydration energy and the lattice energy. Energy required for hydrating a molecule means to add water, and lattice energy is energy required to form a proper crystal lattice, right? A proper structure. Addition of water. This should be addition of water. Okay. Now, the thing is, what is given? We are given the sulfates of the alkaline earth metals, right? One is calcium sulfate, barium sulfate, beryllium sulfate, and strontium sulfate, right? Now, forget about the sulfate part. Let's not think about it. Considering the cation part of the question, what can we write? That first comes beryllium, right? Then comes magnesium, then comes calcium, then comes strontium, then comes barium, and then we have radium. Forget about that. But then this is not mentioned to us. This score is mentioned to us. So this is the order. Down the group is this order, right? Now we know that down the group the atomic size increases. So if the size increases, then this charge, the +2 charge, will be spread out in a larger area as compared to beryllium. Beryllium has a smaller size and also a plus charge, right? So the plus charge will be located in a very small area, right? Compared to barium, which has a larger size. So the plus charge will be dissipated or moving over a greater area. So in this case, in case of barium, you are not going to get the effect of the charge very much as compared to beryllium. So if its size is small and it has a good amount of charge located in it, so it can attract the water molecules very easily when dissolved in water because of its high charge density. It will attract the water molecules. So it will easily form. Why? Because it will have its charge located in a smaller region, so the charge will be rich and it can attract the water molecules easily. So it will have a higher hydration energy, correct, compared to barium. Now compared to lattice energy, comparing lattice energy to this. Now lattice energy is the energy required to create the salt, that is barium sulfate or calcium sulfate in this case. Now if beryllium has a very small size and sulfate is a very large radical in terms of size, so there will be a size mismatch when it comes to beryllium, whereas the overlap will be very good for barium because barium also has a larger size and sulfate also has a larger size, right? So for them, the overlap between the atoms will be strong, and so they will want to form that sulfate, and that will be a stable species, right? But in case of beryllium, that will not be a stable species because beryllium is a very small entity, so its lattice energy will be lesser, whereas its hydration energy will be much higher as compared to its lattice energy. So that is why the answer to your question would be beryllium sulfate will have a greater hydration energy than its lattice enthalpy. Right? I hope the justification and the reasoning is clear to you. Alright. Now the next question is a very smart question. It's nothing to do with any kind of calculation or anything. It is just pure basic knowledge or logic, if you might say so. It's given the first ionization potential of sodium is 5.1 electron volt. Now, whenever you read this sentence, the first thing that should come to your mind is what is ionization potential? What do you mean by this value? So, ionization energy or ionization potential is the energy required to remove an electron from the outermost shell of the sodium. Which means if sodium has an electronic configuration of this 281, then the energy required to remove this one electron from its outermost shell, right, is your ionization enthalpy. That is given to you as 5.1 electron volt. The question asked to you is what will be its electron gain enthalpy or electron affinity. Okay. Now, whenever you are wanting to remove an electron, you will require to add energy. Correct? Now, electron affinity means what? You are wanting to add an electron into the element. So, if you are wanting to add an electron, you will have to release some amount of energy to balance the two. Right? So, we can actually say that the ionization energy and the electron affinity is just opposite properties. Opposite to each other, right? So the ionization energy, if it is 5.1 electron volt, then the electron affinity would be the same value. There shouldn't be any change to gain back that electron. But what change should be there? There should be a change in the sign. The answer should be minus 5.1 electron volt. Why? Because in case of electron affinity, whenever we are gaining an electron, we have to lose some amount of energy. So this minus sign denotes that losing of energy. So it's an entirely conceptual question. Your answer would be B. There is no calculation as such involved in this particular question. Alright. Now moving on to the last question of our series today. That is, question says the correct order of radii, and there are 4 options given to you. So we have to justify and analyze every option separately to answer this question. Alright. So let's start. The first option says, I read the question wrong. The question was the correct order of ionization potential is, and there are 4 options mentioned, not atomic radii. It was ionization potential. So the first option given to us was potassium, sodium and lithium. This is the order mentioned to us. So first things first, you have to write down the electronic configuration of the elements. That's the basic basic starting point. Alright. Now for lithium, what can we write? This should be 1s2 2s1. Right? This should be neon core 3s1. This should be argon core 4s1. Correct? So now all of them have an outermost configuration of s1 structure. Right? So this is difficult to predict. Now how would we use? We would use a junior concept that ionization energy down the group decreases and across a period it increases. How do we know? Because across a period the attraction of the nucleus on the outermost electrons increases. Why? Because the number of electrons are increasing in the outermost shell. Right? So if the attraction increases, it will be difficult to remove the electron. So we will have a higher ionization energy across a period. But down the group, as the shell number increases, the distance from the nucleus is going on increasing. Right? So the nuclear attraction on the outermost electron decreases, and so we will need lower amount of energy to remove the electron. So down the group, ionization potential should decrease. But the order mentioned to us is that down the group, the potential energy, ionization potential energy is increasing, which should not be the case. So that option is not correct. Now moving on to the second option. It says beryllium, magnesium and calcium. Now let us first understand the order of it. So down the group it's beryllium, magnesium and calcium. So we have just discussed the ionization potential decreases down a group. So beryllium should be ideally having the largest one, which is correct. So this option is our answer. Already we have got the answer, but then we need to verify the other options as well. The third option says, so our answer is option B, but just let's check the other ones. The third option says boron, carbon, nitrogen. Now we know boron, carbon, nitrogen, oxygen, they belong to the same period. So across a period, the ionization energy should increase across a period. Right? So nitrogen should be having the highest ionization energy, but in this case it is showing boron, so this is not a correct option. And the last option says germanium, silicon, carbon. So germanium, silicon and carbon fall in the same group. Carbon, silicon, germanium, tin and lead. Alright. So down the group ionization energy should decrease, but it's showing that germanium is having a higher ionization energy. So this is not the correct option. So we can infer from this justification that our option B is correct. So I hope the questions on periodic table are clear. The kind of questions that come for your exam are clear to you. Basically, the question revolves around your atomic size, ionic size, ionization potential, electron affinity. These are the kind of questions they ask from this chapter. Which is why I have selected those kind of questions which can show you different concepts at the same time. I hope those solutions are clear. If you have any doubts regarding any solutions, you can just drop it down on the comment section below so that we can get back to you. Till then, keep revising, and if you have any suggestions on which chapter or which topic to start off next, we can work on it. So stay safe and keep revising.